In this video, we're going to take a look at incenters, another special type of what we call centers of triangles. The angle bisectors of the angles of a triangle intersect at a point called the incenter. So let's write that in that first set of blanks in your notes. The angle bisectors. So a nice picture of an angle bisector is up there at the top of the page. It divides the angle into two equal angles. The incenter is always equidistant from the sides of the triangle. So for example, DP, EP, and PF, or PD, PE, and PF would be an easier way to name those, are all congruent. So it says list the angle bisectors. So let's do that first. We have angle bisector BP. We have angle bisector AP. And we have angle bisector CP, because they go from the angle through the angle and they break it into two equal smaller angles. It says name the incenter. So the incenter is named in this case P. And then it says list all congruent segments. So that's what I was starting to do earlier. These three little segments that go from the incenter to the side of the triangle are all congruent. So let's list out PD, PE, and PF. And then we also know that these triangles that are created in the corner of each corner of this larger triangle, there's two triangles that end up being congruent. And so we actually have BD is congruent to BE. So let's write BD is congruent to BE for this example. And let's grab another color. This triangle over here in this corner is congruent to the one beside it. So we would say that AD is congruent to AF. And let's grab one more color. We can say that these triangles in this third corner of the larger triangle are congruent. And so we can say that EC is congruent to FC. So EC would also be congruent to FC. Okay, so let's use these rules to take a look at three examples dealing with incenter. Example 1 says if P is the incenter of triangle JKL, find each missing measure. All right, so given what they've shown us in the picture, we could label that each one of these little segments that goes from the incenter to the side of the triangle would all be congruent. So we know that each one of those would equal 8. They've given us 17 for OK, so we know that NK would also be 17 based on the hypotenuse leg theorem. Those two triangles in that corner are congruent. And then they share that hypotenuse right there. And then we're given the 13 for PL. So let's see what we need to find. NP, we know we just labeled is equal to 8 because that's one of the segments from the side of the triangle to the incenter P. NK we've already labeled. We know that's 17. And we need to figure out PK. So PK is the hypotenuse of those triangles. So we can use Pythagorean theorem to figure that out because we know that one leg is 8 and the other leg is 17. So we need to say 8 squared plus 17 squared would equal, and I'm just going to name it like it looks on the figure. PK is the hypotenuse. Normally we say A squared plus B squared equals C squared, but I'm going to call it by the name of what's in the figure. All right, so let's bring up our calculator. Let me scoot it over here. Let's figure out what is 8 squared plus 17 squared. We can type all that in at once. We get 353 equals PK squared. So we just got to take the square root of 353. And we get about 18.8. All right. Here, let me move that over here out of the way. All right. So PK was equal to 18.8. And then LO is part of this triangle in the corner, like another corner of the larger triangle. We know that the hypotenuse of that little right triangle right there is 13 and one leg is 6, and we're looking, or excuse me, one leg is 8. Let me write that 8 a little bit better. One leg is 8, the hypotenuse is 13, and we're looking for the other leg, so we need to use the Pythagorean theorem again. So we would say 8 squared plus LO squared equals 13 squared. So that would be 64 for 8 squared and 169 for 13 squared. So let's say 169 minus 64. And we would say LO squared equals 105. And then we just have to take the square root of 105 and round it off. So we get about 10.2 is the length of that little corner, LO. All right, so using the rules for incenter and a little bit of Pythagorean theorem, we figure out all the missing pieces for example 1. I'm just going to move this back up here where we have room for example 2. All right, example 2 says, if G is the incenter of triangle ABC, find each missing measure. So let me just move the calculator to give us more room to work. So they want us to use what's given. So let's label everything we know based on the picture. So we know that these 3 segments that go from the side of the triangle to the incenter are congruent. We know that if DC is 35, so is FC. Those are congruent. And BE is 6. So we also know that BF would be congruent and be also equal to 6. So that answers a couple of questions they've asked us about. Let's see, GD we don't know yet. BG we can figure out in a minute. FC we said was 35. So let's go ahead and answer that one. And then BF we have said is equal to 6. So then let's work on the first one we need Pythagorean theorem for. So GD is right here. And we have 2 sides of this right triangle, so we can use it to figure out that missing piece. So we can say the hypotenuse is 37, one leg is 35, and we're looking for the other leg, which is GD. So I'm going to say GD squared plus 35 squared equals 37 squared. So let's just use our calculator to help us out, because those are some big numbers. Clear everything out so it's nice and clean in Desmos. So we need GD squared. It's kind of like A squared or B squared. I'm just labeling it as it looks in the figure. Then I'm going to type in 37 squared minus 35 squared. So that'll just save me some work. Here, I'll scoot this down a little bit and write that in there. So that's all I did, and I got GD squared equals 144. And then when we take the square root of 144, GD would just equal 12. All right, so one last piece is BG. So if you notice, BG is the hypotenuse here. I need to erase that one little tick mark. The hypotenuse, and we know that BF is 6, and then EG would equal 12, because we just figured out that these little pieces are 12. So we know 12 and 6 are the legs of this little triangle, and we have to figure out the hypotenuse, BG. So we need Pythagorean theorem one more time. I'm just going to draw that little triangle in pink to keep it separate from the other one. So let's say 6 squared plus 12 squared equals BG, which is the hypotenuse squared. So 6 squared is 36. 12 squared is 144. So that would give us 180 equals BG squared. So we just got to take the square root of 180. And we get 13.4. So about 13.4 is the length of that last segment they were asking us about. So let's write that over there. And now we have everything we need for example 2. All right, so just one last example with incenter. Number 3 says if S is the incenter of triangle PQR and the measure of angle PRQ is 8x minus 10. So let's label PRQ is 8x minus 10. Angle RPQ is 4x minus 14. And angle PQR is 7x minus 5. Find each missing measure. So notice they want all of these angle measures for your triangle. So let's start by noticing that this is all going to add up to what a triangle adds up to, which is 180. So since these 3 angles they've given you all form a whole triangle, let's just add them all up to 180 to figure out x first. That's the first step. So 4x minus 14 plus 7x minus 5 plus 8x minus 10. Let me just scoot that over a little bit. That would all equal 180 is our first step. Then we need to combine like terms. So we have 4x plus 7x would be 11x plus 8x would be 19x total for all of our x's. Our x terms. We have negative 14 plus negative 5 would be negative 19 minus 10 is negative 29. All equals 180. We can add 29. So we get 19x equals 209. And then let's divide both sides by 19 and see if that comes out evenly. Bring that back up. Let's see. Okay, so let's say 209 divided by 19 is, 11. So if x equals 11, it's going to help us answer the questions, but it just hasn't, we don't have any angles yet. So we got to plug it back in. So 4x minus 14, let's start there. 4 times 11 minus 14. We'll just type it in. So 4 times 11 minus 14 would be 30. So angle P is 30 degrees. Then let's figure out 8 times 11 minus 10. So that would be 88 minus 10, which would be 78. And then 7 times 11 minus 5 would be 77 minus 5 is 72. So we have 72 degrees. We got 30 degrees, and we have 78 degrees. So that's going to answer some of these questions, and then we can figure out the rest. Angle, let's scoot that out of the way. Angle PRQ, so we now know that that angle was 78 degrees. Angle RPQ was the red one, so that was 30 degrees. Angle PQR was just our green one, that was 72 degrees. And then angle RPS, let's see, RPS. So notice that that's half of this red angle, and each one of those is bisected, or like the larger angle RPQ is bisected. So RPS is congruent to angle SPQ. And then they would both have to be 15 degrees because 30 degrees divided by 2 means both of those would equal 15 degrees. So let's write that one down. And then PQS is down here with the green angles. So if we divide 72 divided by 2, we get 36 degrees for each one of those, if they ask for the other one. And then the measure of angle PRS is half of the blue angle, because PRS is right here. So half of 78 would be 39 degrees for each one of those angles, because each one is bisected. That's how an incenter was created, was by angle bisectors. And then angle PSR. So let's see, PSR. They're asking us for this angle. So you've actually got to use your triangle theorem that all triangles add up to 180 for their angles. And we know 2 of these angles, so we just have to figure out the third one, we've made quite the mess on our paper. So let's see. We've got 15 degrees is this one over here, and 39 degrees was down here. So we need to do 180 minus 39 minus 15. Or we can add those together first. A lot of you like to do it that way. 39 plus 15 would be 54. So let's say 180 minus 54 would be 126 degrees. All right, so that's it for examples with Incenter.